Okay, so looking at number 5, we want to write the factored form of the polynomial that's shown in the graph. And we've got a real zero here at -5, and that is a cross. So we know that there is a linear factor of x plus 5. Okay, then at +1, we have an x-intercept, and that is also a cross. So that's a linear factor of x minus 1. Then we have another real zero here at +5, which is another cross. And so x minus 5 is a factor. And then looking at the end behavior, we see that this graph starts up on the left and ends down on the right. So that tells us from the leading coefficient test that this is an odd degree and a negative leading coefficient. So I know that my polynomial has to have a negative out front, and that would be the equation that represents this graph. And I can see that it's a degree 3 polynomial, so it's odd degree and negative leading coefficient. In number 6, we have both ends headed up to positive infinity. So that tells me that this is an even degree polynomial with a positive leading coefficient. So I won't need to worry about starting out with a negative since both ends go up. Then looking at my zeros, here at -5, there's a cross. So that would be a factor of x plus 5. Then at -1, we have a bounce, and bounces have even multiplicity. So we'd have a factor of x plus 1, and then if I'm doing least degree, this would be multiplicity of 2 on that factor since it's a bounce. But since it just says a factored form of each polynomial, it doesn't require it be least degree. This could be any even exponent other than 0. So you could have 4, 6, 8, 100, right? Any of those would produce a bounce. Then at +5, we have a cross. And so that linear factor of x minus 5 would also be in our factored form. So this is degree 1 plus 2 is 3 plus 1 is 4. So even degree, that works. Positive leading coefficient, and that would be the factored form. Okay, then in problem number 7, we have at -4 a wiggle through that real zero. And wiggles, remember, have odd multiplicity. So the factor of x plus 4, I'm going to make cubed. The odd multiplicity has to be an odd number greater than 1. So you could also do a 5 or a 7, 9, 11, any odd number greater than 1 as the multiplicity on that factor. Then here at the origin, we have a cross, and so that's a linear factor of x. Then at +3, there is a bounce, and that has to have even multiplicity. So the factor x minus 3 needs an even exponent greater than 1. I'm going to use 2 for the least degree, but a 4, 6, 8, 10, 12, any of those would be fine. Then looking at our end behavior, both ends are headed down toward negative infinity. So we know this is an even degree polynomial with a negative leading coefficient. And so I need a negative out front, and that would be the equation of the graph in factored form.